Okay, so in section 5.2.1 of your reference handbook, this is the first slide where I'm referencing the reference handbook. You'll see the standard form of a chemical reaction and some standard equations. So the first thing you should be aware of is the difference between a reversible and irreversible chemical reaction. So a reversible chemical reaction, again, is a reaction where you have a double arrow sign, right? And the reactants are forming products, but the reaction can also move from products to reactants in the reverse direction. Irreversible reactions only move from left to right. And of course, the standard convention is reactants are on the left side, products are on the right side. The lowercase letters, A, B, C, and D, are your stoichiometric coefficients. The uppercase letters, A, B, C, and D, are your elements or compounds. And this is the standard convention for a chemical reaction. Now, this doesn't mean that every question is going to have just two reactants and two products. This is just an example form here. Now, how do you determine the actual rate equation? So for the purposes of your exam, V is constant for all situations where you're looking at this general rate equation. And the rate equation with respect to component A is minus R sub A. R represents the rate of... Can anyone tell me why there's a negative sign here? Just curious if... who knows why? Yeah, so Stephen is correct. So the one distinction you want to make is signs are important for kinetics problems. So a negative sign indicates that whatever you're looking at, whatever compound, is being consumed. So it has to be a reactant. So with respect to A, in this standard equation, A is a reactant. So that's why the rate of conversion of A has a negative sign associated with it. So the rate of conversion of A is equal to this differential form, which is the rate of change of concentration of component A over time. So you're not solving differential equations on the exam. So let's take a look at the integrated form here. Minus R sub A is equal to K times C sub A to the n power. K is your reaction rate constant. C sub A is your molar concentration. And then when I say molar concentration in SI units, that's always moles per liter. That's the standard units you'll see on the exam. N is the reaction order. The reaction order is either given to you in the problem statement, or you have to determine it using you have to look at either the equation, or you can also look at the reaction rate constant, and then we'll go through some problems on how you determine what the reaction order is. But one thing I want to point out is on the exam, you're not always given this convention, C sub something, for concentration. You should be aware that bracket A in closed bracket to the n power, that symbol also represents molar concentration. So make sure you're aware of both ways molar concentration can be represented. So again, R is either your rate of conversion of A, or if you're dealing with a product, rate of disappearance, and it's the rate of that reaction, and the units in SI units are mole over liter times second. K's units are dependent on this formula here. And this formula is in your reference handbook. It's actually in the, if you look at page 206 of your reference handbook, there's a table of units. And if you go to the row for K, reaction rate constant, you can see they've included the units with the formulas that have N for both SI and US units. So that's where you can look this up on the exam.